Hello and welcome students. This is a lecture on straight lines. This is a lecture on straight lines. Earlier to this, we have had I suppose 2 or 3 lectures on straight lines we have had, and in that I have given you the ideas about a locus. We have studied what is a locus. Then we solved several problems on finding the equation of locus. We defined locus, then we wrote the steps which are involved for finding the equation of a locus. Then we solved some problem where we found the equation of locus. Then we also learned in the same topic the idea about shift of origin. Shift of origin we studied, that how do we shift the origin and what happens when the origin is shifted. And then how does the coordinates of a point change when the origin is shifted? That is, old coordinates of a point, new coordinates of a point. Then we also studied how does the equation of a locus change when the origin is shifted. All this we did in the topic locus. Then we started with the topic straight lines. And in straight line, I had begun with some important points which I said, important terms which I said are very, very essential for learning the concepts of straight lines. So in that, we have already studied what is inclination of a line. We have already studied inclination of a line. In detail, we have studied this. Then we have studied slope of a line. Slope of a line. That is, inclination of a line is theta and slope of line is tan of theta. Then we studied slope of a line when 2 points on the line are given. Slope of a line when 2 points on the line are given, on the line. That is, when we have ax1 y1 and bx2 y2, then how do you write the slope? That is, you use the formula m equals to y2 minus y1 upon x2 minus x1. This we have done. Then after that, we learned about parallel lines. We learned about perpendicular lines. And then we started solving problems. We have completed exercise 5.1. We have completed exercise 5.1. Sorry. Yeah, 5.1 and 5.2. From the textbook, we are following the textbook, that is Maharashtra State Board textbook. So we have already completed 2 exercises. Now today we are going to go ahead and see what is the agenda of this lecture. What are we going to do in this lecture? I will tell you in short. In this lecture, I'm going to teach you intercepts of a line. See students, I will give you the idea about intercepts of a line. See, there are few problems in exercise 5.2 which are based on intercepts of a line. So that I will teach you intercepts of a line. Now remember students that there are 2 types of intercepts a line has. That is, it has x-intercept and y-intercept. Remember students that these 2 intercepts are very important concept as far as the line is concerned. You know, these are very, very, very important concept as far as the line is concerned. X-intercept of a line and y-intercept of a line. These 2 are very important. We will do this. And after that, we will start with equation of line. We will start with equation of lines. And in equation of lines, this is very important part. And in this, we will see the equation of x-axis. We will see equation of y-axis. We will see the lines, equation of lines parallel to x-axis and parallel to y-axis. And something more, definitely we will, as the time permits in the lecture, we will do it. Let us begin with the intercepts of a line so that we can complete exercise 5.2. So here I begin with, see, I will write here intercepts of a line. Intercepts of a line. So what I do here is, students, let me first draw the coordinate axis. So here I draw the coordinate axis. That is, I draw y-axis and x-axis. See, this is our coordinate axis system. This is our 2D system. This is y-axis, x-axis. They intersect each other at O origin. This side we write as x dash and we write as y dash. Now, students, I have, see, on the x-axis we write on the right side we write positive numbers 1, 2, 3, 4, 5, 6, and so on. This side we write negative numbers. So right now I'm teaching you intercepts of a line, and in that, the first we go for is x-intercept of a line. What are we doing? See, a line has, any straight line will have two intercepts. We define two intercepts of a line, x-intercept and y-intercept. So right now I'm doing x-intercept of a line. We are doing x-intercept of a line. Okay. So now what I do is, see, I have a line here, and this line cuts the x-axis at 0.3. See, it is cutting x-axis at 0.3. Where is the line cutting x-axis? It is cutting x-axis at number 3. Okay. Now remember, students, there can be, now this line is cutting x-axis at number 3. At number 3, there can be other lines also which can cut x-axis at number 3. See, this line is also cutting x-axis at number 3. I can have another line which is cutting x-axis at number 3. It is, see, these all lines are cutting x-axis at number 3, but they all are different from each other. You have to agree, right? Now see, students, these all lines have x-intercept 3. What we will say? We will say, if I call all these lines as L1, L2, if I call them as L1, L2, L3, L4, okay, then I will say that these lines have x-intercept as 3. What is their x-intercept? The x-intercept is 3. Why? Because they all are meeting x-axis at 3. So here I will say lines, from the diagram I will say lines L1, L2, L3, L4, and L4, and L4 have x-intercept, equals to 3, equals to x-intercept equals. Okay, this is something very easy which I went ahead with for making you understand. But see, how do we define it? If I have to define, then how do I do it? Okay. So if I have to define x-intercept, what do I do? Let me have another line here. Let me have another line, and I will define it with the help of that line. So here I have a line, and see, students, this line, say this line is line L. This line is line L. Now you all know that this line cuts the x-axis at number 2. Now this point where it is cutting x-axis, let this point be A. I write the point as A. I write the point as A. This point is A. Remember, the point is here. The point is here. And its name, the name of the point is A. The point is here and its name is A. Okay. So the line meets x-axis at point A. The line L meets x-axis at point A. Now I will write the coordinates of point A. What are the coordinates of point A? See students, the y coordinate of point A is 0. This point, since it is on x-axis, so the y coordinate is 0. And what is the x coordinate of this point? It is 2. The x coordinate is 2. Okay. So I understand that x-intercept of line L is 2. The x-intercept of the line L is 2. Also, the x-coordinate of the point where the line meets x-axis is 2. So now I can have the definition. See, how do I define? I write x-intercept of a line, x-intercept of a line is the x-coordinate, is the x-coordinate of point of intersection of line with x-axis. Line with x-axis. Tell me students, have you all followed it?
Yes, sir.
So this is the x-intercept of a line. Now suppose if I have another line here, I have another line here, say it is meeting x-axis at point B, and I write the coordinates of B. It is -3, 0. The x-coordinate of this point is -3, and the x-intercept is also -3. So x-intercept of a line is the x-coordinate of the point, x-coordinate of the point of intersection of line with x-axis. One thing is sure, student, that to get x-intercept of a line, the line must intersect x-axis. The line must intersect x-axis. Yeah, now see students, you must notice that these lines, L1, L2, L3, L4, then this is L, say this line is L5. These lines are not, it is not that they are intersecting only x-axis. These lines they are also intersecting y-axis. They are also intersecting y-axis at different points. Now remember students, a line will have, along with x-intercept, it will also have y-intercept. But here we are giving emphasis in this diagram. Since I was teaching you x-intercept, we did not actually speak anything about the intersection of lines with y-axis. That is, we did not speak about the y-intercept. Now we are going to talk about y-intercept. See here. So the next thing that we will talk about is y-intercept of a line. Very simple students, as we spoke about the x-intercept of a line, now y-intercept. And one thing is very clear, that for y-intercept of a line, the line has to intersect the y-axis. So suppose I have a line here, which intersects the y-axis at 4. At 4, a line intersects the y-axis at 4. Okay. Now remember that there can be infinite lines which will intersect y-axis at 4. There can be infinite lines which intersect y-axis at point 4. And remember that these all lines have y-intercept 4. See, they will definitely intersect x-axis also, but in this example, we are not interested in this. So here what I will say, listen, I will say here that say this is L1, L2, L3, L4, L5, okay? I will say the lines, I will say here lines L1, L2, L3, L4, and L5 have they have y-intercept equal to 4. Now see, if all these lines say cut x-axis, y-axis here, then they would all have y-intercept 3. If they cut here, then y-intercept 2. If they cut here, the y-intercept is 1. If they cut here, the y-intercept is 0. If they cut here, then -1. If they cut here, -1.5, and so on. Yeah. So in order to now, I will try defining the y-intercept, and in order to do that, what I will do is let me have a line here and say the line is say here, okay? The line is meeting y-axis at a point, and the name of the point is say A. Okay, the name of the point is A, or for that matter, I can take B because we have taken A in the previous one. So this is the point where line meets y-axis. Remember, student, for y-intercept, we are taking the line, we are taking the point where line is meeting y-axis, the line where it cuts y-axis. So this is B. And remember, students, the x coordinate of B is 0 and y coordinate is -1. The x coordinate of B is 0 and the y coordinate of B is -1. The point B is on y axis, so the x coordinate is 0. You saw in the previous one, the y coordinate was 0 because the point was lying on x axis. Here, the point is lying on y axis. Okay. Now see, students, what is y-intercept of this line? Say this line is L. What is the y-intercept of this line? The y-intercept of this line is -1. It is -1, right? Because the line meets y-axis at the number -1. And also the y coordinate of the point, where the line meets y-axis is -1. So now I can define the y-intercept of a line as follows. See, how do I define? I write here y-intercept of a line. This is definition. Y-intercept of a line is the y coordinate of point of intersection of line with y-axis. Remember, what had you written for x-intercept? You wrote x-intercept of a line is the x coordinate of the point of intersection of line with x-axis. Here you write y-intercept of a line is the y coordinate of the point of intersection of line with y-axis. Okay, I hope you followed it. You will now copy this. Here we have a question, student, based on the concept that we did. It says, if the x and y intercept of line L, are 2 and 3 respectively, they give us the x-intercept and y-intercept of the line as 2 and 3. Then find the slope of line L. We have to find the slope of line L. So I start with the Answer C. What is x-intercept of line? X-intercept of line equals to 2. Now you know, students, y-intercept of line is 3. Okay. Now you know, if x-intercept is 2, it means that on x-axis you will have somewhere number 2. You will have somewhere number 2 here, and the line which they are talking about, this line will meet the x-axis at this point. Okay. And the y-intercept is 3. It means on the y-axis you will have somewhere number 3, and the line will meet y-axis at this 3. So what would that line be? The line, how would that line be? The line would be like this. You see this? Meeting x-axis at 2 and y-axis at 2. Now see, if that is the case, then see this point which I have on the line, this point which I have on the line, and this point which I have on the line, one of them is on x-axis, the other is on y-axis. Think of the x-coordinate of this point. It is 2 and y is 0. And the coordinates of this are 0 and 3. You understand? I take this point as a B. If I take this point as a B, then you know, this being y-axis, this is y-axis. What will happen if I take this point as a B, then the coordinate will be 0, 3. Okay. So I can say here, I can say, therefore, 2, 0 and 0, 3, 2, 0 and 0, 3 are 2 points on the line, Remember that, student. 2, 0 and 0, 3 are 2 points on the line. Why 2, 0? Because the x-intercept is 2. You can check 2, 0. And why 0, 3? Because y-intercept is 3. You can check here 0, 3. So 0, 2, 0 and 0, 3 are 2 points on the line. Now, once I know 2 points on the line, you know the slope of the line can be calculated with the help of the formula. So I'll write slope of line equals to y2 minus y1 upon x2 minus x1. So it is y2 minus y1 upon x2 minus x1. That is 3 minus 0, see, 3 minus 0, y2 and y1. So 3 minus 0 upon 0 minus 2. The answer is minus 3 by 2. This is the slope required. You can copy this. So here we have a question, students. A line makes intercepts 3 and 3 on the coordinate axis. That is, the x and y intercepts both are 3. See, 3 and 3 on coordinate axis. Now you understand, when they say coordinate axis, first we will take x and then y. And here they are saying 3 and 3. So first is x-intercept and the second is y-intercept. So both are 3. Now, if that is the case, they want you to get the inclination of the line. Okay. Now, see, for this, the idea is I will first find out the slope of the line. So we are given x and y intercept. So we will, from x intercept, I get the point on the line as 3, 0. And from y intercept, I get the point on the line as 0, 3. Now I have 2 points on the line. I can find the slope of the line. So here I will write, therefore, slope of line equals to y2 minus y1 upon x2 minus x1. 3 minus 0 upon 0 minus 3. That is minus 3 by 3. That is minus 1. This is slope of the line I got. Now remember, students, I got the slope of the line. And what they want is the inclination of the line. I write, see what I will write. I write, we know that slope of a line equals to tan of theta, where theta is the inclination, Now here they give me slope as -1. So I can say tan theta is -1. So I will write therefore tan of theta is -1. Got it? Tan of theta is -1. Now remember students, tan theta is -1. Tan of theta is -1. We have done this. We have done all this in trigonometry. When tan of some angle, remember students, when tan of some angle is negative, if tan of some angle is negative, then you understand that this angle is not in first quadrant. Just apply the ideas that you have studied. This angle is not in first quadrant. Okay, so from this I understand that the line which I have, the line will not be inclined this way. No, the line is not inclined this way. The line I understand that line is not like this. You understand, line is not like this, no. No ways, the line cannot be like this. Why? Because if the lines are like this, then all the inclination is lesser than 90 degree, and all the inclinations theta is in first quadrant, and tan of such angle will be positive. So now I understand that in this case, how is the line? The line is having inclination. The line is not like this. See, this is not the way the line is. All such lines have inclination. All such lines have inclination, positive inclination lesser than 90. So they will all be having once again, students, see all these lines have inclination lesser than 90. You can check these all angles are less than 90. So what way our line is? Our line is having inclination more than 90. See, this theta is more than 90. That is why tan of theta is coming negative. It means the line that we are right now concerned with is this way. It is this way. And that's the fact. That is the fact, student, because see, the x-intercept, what are we given? The x-intercept is 3 and the y-intercept is also 3. So see here, this point is 3, 0 and this point is 0, 3, the coordinates. Okay, and see the line, how the line is? The line is inclined with x-axis in such a way that inclination is more than 90 degrees. See, inclination, you know the definition of inclination. It is the smallest angle made by the line with the positive direction of x-axis. See, this is inclination, and this theta is greater than 90 degree. Okay, so that I have understood. So see, now how do I find this tan of theta? Remember, students, if I have for some angle, say tan of alpha is 1, then this alpha is 45 degree. Tan 45 degree is 1. Okay. And remember, students, tan of 135 degree is -1. Tan 45 degree is 1. Tan 135 degree is -1. Okay. This you should remember. For now, what I'm suggesting you is, as you remember tan 45 degree is 1, you should remember tan 135 degree is -1. How is 135 degree? It's very simple, students. It is 45 degree. It is 45 degree after y-axis. See, it is 45 degree. See, how is 45 degree? See, this is 45. This is 45, right? Now this is 45 more, so it is 90. Now 45 more. So see, 45 plus 45, 90, 90 plus 45, 135. So remember students, tan of theta is -1, so theta is 135 degrees. See, this angle is 135 degree. This angle is 135 degree. If you remember, you can solve it faster. There is one more method of solving. I will teach you that also. In case if you do not remember, how do you solve? See, for that, I will help you out this way. See, tan theta is -1. Tan of theta is -1, right? So see, in the next step, I can write, therefore, minus of tan theta is 1. I'm shifting this negative sign here, okay? Tan theta is -1, so minus of tan theta is 1. Yes. Next step I write, therefore, see, this is minus of tan theta. I know tan of 180 degree minus theta. If I ask you what is tan 180 degree minus theta, if I ask you what is tan 180 degree minus theta, see, I ask you tan of 180 degree minus theta. So what will happen here? See, tan 180, you know, if it is even multiple of 90 degree, see, this is 2 times 90 degree. So tan will remain tan and theta. Then which quadrant this angle lies in? This angle lies in second quadrant. 180 minus theta is in second quadrant. So what you will do? You will write here tan in second quadrant angle is minus tan theta. You got that? It is minus of tan theta. So see students, tan 180 minus theta is minus tan theta. Tan 180 minus theta is equal to minus tan theta. So what I'm doing? I'm doing the same. For minus tan theta, I wrote tan of 180 degree minus theta. See, minus tan theta and this, they are same. Now what I will write? Equals to 1, equals to 1. Next I will write tan of 180 degree minus theta equals to, now see, this is 1. Can I write this as tan 45 degree? Yes, 1 is tan 45 degree. Now I have what? See, tan 180 minus theta is tan 45. So 180 degree minus theta is 45 degree. So therefore, I shift 45 here and theta there. So I get 180 degree minus 45 degree equals to theta. This implies theta equals to 135 degree. I would suggest you go by this method. Just remember it. Tan theta is -1. It means theta is 135 degree. Okay. See how easy this is. How easy this is. Why easy? Because you understand. See, tan of theta is negative. It means theta is greater than 90. And greater than 90, how much greater than 90? Greater than 90 by 45 degree more. So 90 till here it is 90 and 90 plus 45 is 135. This angle is 135. Tan of theta is -1. So theta is 135 degree. So having done the intercepts of a line, now it is time we started with the equation of lines. See students, the next part that we are going to do is equation of line. Equation of a line. Equation of a line. Now, first of all, we have to understand that why do we write equation of a line? Now, it is needless to say, students, that a line is a locus. When you say a line, don't you see that a line has infinite points on it? So when a line has infinite points on it, we understand that a line is a set of points. What is a line? A line is a set of points. So if it is a set of points, it is a locus, and if it is a locus, then we can distinguish between one locus from the other locus only with the help of an equation. Now suppose you have you have these many lines. This is nothing. This is nothing. I've drawn about 20 to 25 lines. Okay, and say this is your X and Y axis. Okay, so this is Y axis, this is X axis, this is origin, and you have so many lines. So you have, say you have lines from, you have 25 lines here on the plane. Now these, each one of them is different from the other line. So how do I distinguish between these lines? We will distinguish them by writing their unique equations. We will distinguish them by writing their unique equations. So let us start solving this. So let us understand the concept on equation of a line. So students, see, the first thing that we will do is we will go for a line which is parallel to x-axis. We will go for a line that is parallel to x-axis. So here we have x-axis. Now, as I have written numbers on y-axis, definitely we will have number on x-axis also. But why am I writing here numbers on y-axis only? Because I'm going to take those lines. I'm right now concerned with those lines which are parallel to x-axis. So here I'm writing parallel, I'm writing here equation of a line parallel to x-axis. Parallel to x-axis. Okay. Now see students, it is very much clear that those lines which are parallel to x-axis, they will cut the y-axis. So let me have a line here which is parallel to x-axis, and it is cutting y-axis at 3. It is cutting y-axis at 3. Now how do I distinguish this line from another line? Say I have another parallel line here, then I have another parallel line here, then I have another, like this, I have infinite lines which are parallel to x-axis. So see, being parallel is one characteristic of a line. So when I say a line is parallel to x-axis, then you would know that how the line is. Yes. When I say a line is parallel to x-axis, then you know that how the line is. But that does not give me the unique line because I do not know where the line is. I only know, these words are very important. I only know that how the line is, how the line is. I know it is parallel to x-axis. But then I do not know where the line is. I do not know where the line is. This I do not know because there are infinite lines parallel to x-axis. So on what basis do I distinguish one line from the other line which are parallel to x-axis? See students, what I will do is I understand that the distance of this line from x-axis is 3, and it is 3 units above. The distance of this line from the x-axis is 3, and it is 3 units above. And since it is parallel, what will happen? All the points on this line will have the same distance, 3, which is above x-axis. Remember, distance of 3 above x-axis. Don't say only distance of 3, because if you are not specific, then distance of 3 from x-axis can even be down, then that line would be like this, cutting the y-axis at -3. See, this is also distance of 3 down. So here I understand this. Now what I do is, let me take few points on this line. Let me take few points on this line. And those points which I'm taking on the line are, I take here A, point B, C, C, D, E, F, G, H, I, J, and K. I took 11 points. Okay. A, then B, C, D, E. Here you have F. This is G, H, I, J, and K. Right? Now let us write the coordinates of these points. Let me write the coordinates of these points. So point A. Write the coordinates of point A. What is the x coordinate of point A? X coordinate of A is the displacement of A along x axis. And how much is this displacement? It is 1. It is 1. Displacement is 1 on the right side. So the x coordinate is 1. The x coordinate is 1. Next. Now find out the y coordinate of A. Y coordinate of a point is, see, I want y coordinate of A. What is y coordinate of a point? It is the displacement of the point along y axis. See, this way. The displacement along this direction, y axis. How is y axis? Y axis is like this. This is y axis up, right? So I go along y-axis, and when I go along y-axis, I meet point A here. See, this is the displacement along y-axis. And how much is this? It is 3. It is 3. So here I have the y coordinate is 3. Okay. Now come to point B. Write the coordinates of B. What is the x coordinate of B? The x coordinate of B is 2. The x displacement is 2. You can check the x displacement is 2. Okay, so here it is 2. We will write the x coordinate as 2. And what is the y coordinate? The y coordinate will be the y displacement, which is again 3. You see this? The y displacement is once again 3. It is 3 again. That is the displacement along y-axis, 3 here. So 2, 3. Now, if you write for C, C will be 3, 3. If you write for D, it will be 4, 3. See, x coordinate is 4. X coordinate is 4 for point D. For point D, x coordinate is 4, but y coordinate is 3. For E, it is 5, 3. Now, what you notice? You notice that all these points which are lying on this line, they all have different x coordinates, but they all have same y coordinate, which is 3. Further, see F is 0, 3. G is -1, 3. H is -2, 3. I is -3, 3. J is -4, 3. And K is -5, 3. I took here 11 points. You can take 11 crore points. 11 crore points you can take. You can take infinite points on this line. And all the points, you can take infinite points on the line. These all points will have different x coordinates, but they will have all same y coordinate. They will all have same y coordinate. And that is 3, positive 3. So what you say? You say that one characteristic that this line satisfies is all the points have same y coordinate equal to 3. All the points have same y coordinate equal to 3. So now what I do, students, as I have taught you in locus, I will take a variable point x, y on this line. I will consider a variable point x, y on the line. And then I can say that this variable point will have different x, but it will have same y, which is 3, So what is the equation of this line? What is the identity of this line? The identity is, I will say that this line is y equals to 3. What is this line? This line is y equals to 3. Why? Why? Because all the points on the line have y coordinate equal to 3. Because all the points on the line have y coordinate equal to 3. So same way, students, suppose you have a line which is this. Okay, suppose you have a line which is this. So for this line, what will be the equation? The equation of this line will be y equals to 2, because see, all the points will have y coordinate 2. Yes, like this. And if you have a line which is, say, this, an equation will be y equals to 1. If you have a line like this, then this will have the equation y equals to -1, y equals to -2, y equals to -3, y equals to -3. See, these all lines will have equation. See here, this will have y equals to 1. This is y equals to -1, y equals to -2, y equals to -3, y equals to -3. Because once again, if I ask you why is the equation of this line, y equal to -1, the answer is very simple, because this line is made up of infinite points and all the points have their y coordinate -1. The x coordinate is different, but the y coordinate will be always -1. The y coordinate is always -1 here. So you can write here that we can write here that a line which is parallel to x-axis. See, students, so I will write the final statement for this. I will write here a line. See, I write equation of a line, which is parallel to x-axis is written in the form y equals to k. Remember, students, it is written in what form? It is written in the form y equals to k, where k is a real number, where k is a real number. The k is a real number. Now see, students, if the line is above x-axis, then k is positive. The k is positive. And if the line is below x-axis, then the k value is negative. I will write this also. I write here when the line parallel to x-axis is above x-axis, when the line parallel to x-axis is above x-axis, then k is positive. If the line is below x-axis, then k is negative. K is negative. Now I have a question for you students. See, you just saw when the line is above x-axis, then this number k are positive. When the line is below x-axis, you saw that this number k are negative. This number k has negative value. What do you think will be k value if the line is on the x-axis? If the line is on the x-axis, what do you think the k value will be? Remember students, what you thought is correct. The k value will be 0. The k value will be 0. Because remember, this k is actually depicting, what is k depicting? It is depicting the distance of the line from x-axis. So see, this line is at a distance of 1 unit above, k is positive. This line is 1 unit below. This line is at a distance of 2 units below. Now, when the line is on x-axis, its distance is 0. From x-axis, its distance is 0. So remember students, this k will be 0. So what is equation of a line which is on x-axis? It is y equals to 0. Y equals to 0. But then now I have now what I think is, why should we say a line on x-axis? We would rather say x-axis. Why? Because a line which is coincident with x-axis, it is x-axis. So the next thing that we write is, see students, the next thing I write, equation of x-axis, here I write, see, equation of x-axis is y equals to 0. Equation of x-axis is y equals to 0. Okay, there is one more reason. If someone asks you why equation of x-axis is y equal to 0, then you can simply say because every point on x-axis has y coordinate 0. See, this is this point 5, 0. This point 4, 0. This point 4.5, 0. Like this point 2, 0, 3, 0. Every point will have y coordinate 0. Every point will have y coordinate 0. So y equals to 0 is the identity of x-axis. If I say y equal to 0, it can never be anywhere except the x-axis. Y equal to 0. If I say a point has y coordinate 0, you know what it is? It is x-axis. So we have written this also. I hope you understood the equation of lines parallel to x-axis. So students, now the next I'm going to teach you is about the equation of y-axis, and that I will do in the same diagram. So I want you all to be watchful, very alert. See, equation of a line parallel to y-axis. Okay, so here I have taken a line which is parallel to y-axis. I take few more lines parallel to y-axis. See, you can have a line this way. See, this is also line parallel to y-axis. This is a line parallel to y-axis. This is a line parallel to y-axis. Then here you can have a line parallel to y-axis. See, the lines parallel to y-axis are on the right of y-axis and on the left of y-axis. See, like like the lines which were parallel to x-axis, they were above x-axis or below x-axis. Here you have lines on the right of y-axis and on the left of y-axis. Okay, so see, this is how you have, these are lines parallel to y-axis. Now one thing once again that you want to you should be understanding is, when I say a line is parallel to y-axis, I have given a very important characteristic of the line, that how the line is. I have just said that line is parallel to y-axis. So how it is, I have said that it is this way. It is, I have just said that it is this way. But then I have not specified that this way, but where, because there can be infinite lines parallel to y-axis. So I have said how the line is, but I have not said where the line is. Now remember students, in order to identify a line uniquely, you should have how, you should give the information how the line is and where the line is. Okay, so for that I will make you understand with the help of a simple technique, and that technique I had just explained it to you when I took the line parallel to x-axis. See here, let me now consider this line here. Okay, so here I have one point as k. I will take few points on the line. See here I have k, I take L, then this point I take M, this point is N. I cannot take O because O is origin. I take a point P, I take a point Q and R. Okay, so let me now write the coordinates. Look at this. The coordinates of K are -5, 3. The x coordinate is -5. Why? Very simple. For the reason that x coordinate of a point is a displacement. See, here is your y-axis. So you will see the displacement along x-axis. The displacement is 5 to the left. So the y coordinate is the displacement along x-axis is 5 to the left. Displacement along x-axis is x coordinate. So 5 to the left. So the x coordinate is -5. See, all this point will have x coordinate -5. Try to understand. L has the same displacement, that is 5 to the left. So x coordinate is -5. M also has x coordinate -5. N has same x coordinate. P has same x coordinate, and so on. See students, try to understand, when a line is parallel to y-axis, all the points on the line have same x coordinate. All the points on the line have same x coordinate. If a line is parallel to y-axis, then all the points have same x coordinate. So here I write the x coordinate of L, which is -5. And what is y coordinate? Y coordinate is displacement along y-axis. This is the y coordinate. The y coordinate is displacement along y-axis, and you know that is 2. The y coordinate is 2 here. The y coordinate is 3 here. The y coordinate is 1 here. The y coordinate is -1 here, -2 here. So on this line, I notice that y coordinate is changing, but the x coordinate doesn't change. The x coordinate doesn't change. So here -5, 2, -5, 2. Then here I have -5, 1. Then for n, -5, 0. Then here -5, -1, -5, -2, -5, -3. So I can take thousands of points on this line. They all will have same x coordinate -5. So if I say, since we have studied locus, if I say, let us take a variable point on the line which is x comma y, then you would say, sir, this x will be -5. No matter where this variable point be on this line, the x will always be -5. The only thing that will change is the y coordinate of that variable point. X is always -5. So this makes the identity, this is the identity of this line. So here I have x equals 2. So the equation of this line becomes x equals to -5. This is x equals to -3. This one is x equals to -3. Here you have x equals to, this one is x equals to -2. This is x equals to 1. X equals to 2. This is x equals to 4. X equals to 5. Why x equals to 5? Why? Because all the points on this will have x coordinate 5. They will all have x coordinate 5. So what we can say here, students, we can say, now I will make change in this only. See, I can say here, equation of a line which is parallel to y-axis. Let me make it y-axis. Equation of a line which is parallel to y-axis, okay, which is parallel to y-axis. Equation of a line which is parallel to y-axis is in the form x equals to k. You can check, see all these, they are all x equals to k. Is in the form x equals to k, where k is a real number. Remember, students, k can be any real number. It can be a fraction, it can be an integer, it can be negative, it can also be 0. Listen, if I have a line which is on the y-axis, what will be k value? The k value will be 0. Remember, if the line is parallel to x but on the right side, k is positive. If it is on the right side, k is positive. And if the line is parallel to x-axis on the left side, k is negative. Okay, but when the line is on y-axis, then k is 0. So what we conclude from this? We conclude that if a line is y-axis, then equation of y-axis is x equals to 0. See, k is 0, x equals to 0. Or you can also say that every point on this line has x coordinate 0. You can say that every point on this line has x coordinate 0. You know that every point on the line has x coordinate 0. So you will also write when the line parallel to y-axis, is on the right of y-axis, then k is positive. If the line is on the left of y-axis, then k is negative. Equation of y-axis is x equals to 0. See, students, I'm making changes in this only. So here I write when the line parallel to y-axis is on the, I'll select a bit thin pen. So here I write when the line parallel to y-axis is on the right of y-axis. If it is on the right of y-axis, you understand on the right, that is this side. Okay, on the right of y-axis, then k is positive. If the line is on the left, if it is on the left of y-axis. Now what is left of y-axis? That is on this side. If the line is on this side, right? In case negative, equation of y-axis is x equals to 0. I hope you all have followed this. Learn it again and again.